Hello and welcome to another Syvecs help video. This help video is based on our new Syvecs TinyDash unit. The TinyDash unit is a very small 2.4-inch display that fits in the palm of your hand and is designed purposely to get as much data as possible from your engine ECU or engine powertrain setup onto a display that is useful then for the end user. It also features three inputs and two outputs and one single CAN bus connection to be able to interface and connect multiple other sources. So let's get the unit powered up and then get connected and talk about some of the things that it offers and how it's set up. So for the purpose of the video, I'm just going to plug in a USB-C connector to the display unit alone, and that powers up just the backlight display. When I go device connect to the unit, you'll find that the display turns on and prompts you that no calibration is present. So we're going to connect to the unit. Now, if you have got a calibration already that you wish to load into the device, you can do so, or you can just program the defaults, which in 99% of the instances is the best thing to do. In doing that, you'll see that you'll be then presented with the first layout section. So first part to probably talk about is the calibration switch selection area, because this allows you then to be able to change between your LCD layouts. So multiple ways to switch between the calibrations on the TinyDash. First manner is via a physical input for a rotary potentiometer or a Syvecs 12-way cal switch. The other option is via a cal up and cal down switch, and the third option is via CAN bus. Now, the CAN bus option, under the data stream and preset CAN selections, you'll find that some of the OEM manufacturers have a sport switch that's present on the OEM car. And what that is used for, we actually pick up that position and use that to be able to change the cal select position. Now, if you go into our manual that's on the website, you can actually see a list of the supported OEM vehicles and what functions they actually have available on the CAN bus. And if they have the cal selection option ticked, then you will basically find that when changing the sport mode or the drive mode on that car, the cal select switch will change. For most instances, people will wire in a calibration switch, and this is really useful because a lot of the time the engine ECU is quite far away from the actual cockpit of where the display unit will be sitting. So actually having a switch position, cal switch, launch switch, or say TC switch being wired into the TinyDash, you can feed all of that information from the TinyDash to the ECU with just two single wires, the CAN up and CAN high and CAN low. And it's a much easier way of then interfacing additional sensors as well. You could wire in a, say, for example, air charge temp or engine coolant temp into the TinyDash and send that over to the ECU as well, and the Syvecs ECU could pick it up via generic CAN receive. Other ECUs you can do the same manner, and the data stream section is extremely powerful in the transmit and flexible transmit that allow you to set the item length, the identifier, how often it's set, the endianness, etc. Now, we'll go over that a bit more later in the video, but the first purpose is to just talk about how you get your calibration switching working. So in the I/O configuration, let's say, for example, you've got one of our 12-way position switches. You can assign that to a specific input, and then under the sensors area, the calibration switch, you'll need to, for the Syvecs unit, set the input type to thermistor. Now, one thing to remember from our other help videos is any item that's in blue requires a device program. Any green items are live. So we're going to do a device program, and then instantly you can see the cal select has changed to 12 because the voltage on the input is jumped up to 4.8. Now, the 5-volt out variable here you can see is only sitting at 4.86, not actually 5 volt, and that's because we're just purely connected via a USB-C connection. When you power it up via a 12-volt source, that will then go up to 5 volt. So same with the engine ECU, you can basically set the threshold voltages for each of the cal select positions based on the input from your calibration switch, and then that will then change your cal select item here to then be able to link in multiple functions that you want to from the cal select. So I'm just going to unassign this now, so just so go back to cal 1. And what you can then do is in the Cal1 area, you can change between one of these 7 layouts. So doing that, you can see on the screen, I'm changing that now. And you can then have different layout sets for each layout. So for example, we've just got the ACT, ECT. If I was to go to the LCD setup and layout setup here, I'm going to purposely change the ECT and ACT around, program the unit, because it's a blue item, and then what you can do for that calibration switch position, I can change the item set to 2, so you basically have the same layout but the set of data changes. So it's quite useful that you can have, when changing cal position, multiple layout, it's the same layout but multiple items of data. Now the wastegate control section we won't go over in this video, we'll do a dedicated video on that, but the TinyDash unit does have the ability to control a boost control strategy on a car. The low side outputs that are present on the device can actually control an external solenoid, and then the wastegate control from the S6 ECU has actually been ported into the TinyDash, and you can use it for controlling boost, etc. So back to the calibration switch and the other options of way you can do it. So the other option of a way of doing the cal selection changing is via just a single calibration up switch. What you do with that is basically would assign the cal up switch to say the input you wish to use, and then say, for example, we're going to set the input type to thermistor. What that then does is causes the input to sit at 5 volts. And if you were to set your low threshold at 0 and the high threshold as 1, program the unit. If you are then to pull that voltage, that input down to ground, say with a push to make switch, it will cause the cal up select switch here to change to on, and the cal select item will go up. Now I haven't got a switch wired in currently, but I'm just talking about it. And then what you can then do is in the calibration selection reset, you can basically say that when the calibration select reaches, for example, cal select 12 using the cal up selection, it will then reset straight back to 0. And that's really useful because what you can do is basically have one button that is used to then toggle between all of the cal selections, and from that you can set your different layouts for each time the button is pressed. It's a useful feature of doing that. You've then got the calibration selection override, and again you can wire in a button that is assigned to the calibration override, and what that means is that when that button is pressed, it basically, depending on the cal you're in, if you're in say cal 4 and then the cal override switch was to turn to on, it would then jump to the calibration which you've set here in this map. You can actually assign a cal up and cal down switch to a single input source and override and program that, but you will need to make sure that the input types do match. Otherwise you get an error here in the bottom right hand corner to say input type mismatch. What they all need to be is either all need to be set as thermistor or 5 volts. When you do that, the unit then will now come online happily. And what you can then do if you are using, say, a resistive input chain, like is found on lots of OEM cruise control buttons where they have different resistor values that basically tie into a single wire, you can then set the low and high voltage threshold for each position, so that you can then basically have one input that changes 3 switches on the ECU. It's a very useful way of doing that. You can also set up a traction select switch and launch select switch to a single input with a Syvecs cal switch unit and set the voltage thresholds the same as the calibration switch. And then once you've done that and got those working, as I talked about earlier, you can then transmit that data over CAN to the engine ECU. If it's a Syvecs ECU, it's best just to use the generic CAN transmit, because that's basically set in a format which is supported by the generic CAN receive on the ECU, where you'd basically set your identifier, the frequency of how often you want that identifier to be sent on the CAN, the endian setup, MSB for the S7 stream, and then you can basically set your items that you want to set. So I'm going to set our cal select in here, LC select, TC select, and cal override, for example. And then when we do that and basically transmit that CAN, those 3 items or 4 items of data is all being transmitted just by 2 single wires, which the ECU can pick up. It basically saves multiple inputs being used on your engine ECU, and it makes your installation much tidier in the fact that you're only having to run 2 ECUs from your driving area to the ECU area. So it's a big bonus for guys that are running Syvecs ECUs or other engine management systems that are flexible enough to be able to pick up our CAN stream. Now, if you are needed some flexible CAN transmit setup, you can use the flexible CAN transmit, and this is useful because what it allows you to do is basically set your identifier frequency as before, set your content of which item you want to send out, for example, transmit, and then what you can do is set the start bit, the bit count, and the saturation of that item that is sent on the CAN bus. It's really useful, and you can also shift the item position to basically do divides or multipliers if you want to shift it right, say 2 places, to have the bits align for a particular ECU setup. So it's a really useful feature. Now we do have a generic CAN receive where you can pick up external cal select items as well, but you can also then obviously use a generic CAN receive to pick up all the item data from, say, an OEM ECU installation or an aftermarket engine ECU. It's a very powerful setup, and the link at the bottom here will basically talk about how that works and how easy that is to set up. For most people that will be using the TinyDash, I think they're going to be using the preset CAN receive. Having the ability to have been able to decode most OEM ECU CAN bus data basically means that we put that all into a database which can then be used on the TinyDash. You can see multiple OEM car data is available and can be received, and in our manual for the TinyDash at the bottom it shows a list of the cars that are supported and also what functions are supported. What I mean by that is that most of them have RPM, for example, and engine coolant temp present on the CAN bus, but not all of them have, like, say, lambda or fuel duty or cal adjustment. So we basically show that in the bottom of the manual to say which cars have which features. You also see there are some aftermarket ECUs in here as well, ECU Master Link, ECU Motec, etc., where we basically decode their stream, and you've also got the Syvecs S7 fixed stream here, which allows you to pick up that data and be fed into the ECU as well. That way you get all of the item information from the Syvecs S7 fed into the TinyDash with just one click of a button. It's a really useful feature and a way of doing it. The sensors section here allows you to basically wire in and set up these sensors on the TinyDash display also. These are just a small selection of what we've generally found to be most popular and requested by dealers, but we can add additional sensors if requested. You can email support at Syvecs and we can add the sensors that you wish. And that way, like I said before, you can basically grab this data on the TinyDash and then feed that over CAN bus to the ECU if you wanted to pick up, say, an air charge temp sensor or coolant, oil pressure, etc., and feed it over the CAN. Or if you purely just want to monitor it on the TinyDash yourself, then you can do so. The setup for this is generally similar to our engine ECUs, where the input type select 5 volt is purely a 0 to 5 volt input. For Mister basically applies a 3K pull-up to that. You can then set an error threshold for the input type. So for example, if I was to say, let's set assign air charge temp to AN01, program that, we'll then find that the voltage level on the ACTV has gone above the input high voltage error threshold, and in doing so you'll find a device error in here to say that it's out of range. Then it will basically get set to the default sensor reading. Once you've done that, you can obviously linearize your sensor once it is within range, and you can then receive that data. So for the purpose of this video, what I'm actually going to do is going to be a little bit sneaky. I'm just going to clear these gauges and set this voltage error threshold to 5 volt so that the sensor doesn't actually go into error. By doing that, what that allows me to then do in here in the linearization is change the actual voltage, the value of the ACT. So if I just double click on that, you can then see the ACT here is at 49, and you can see it changing on the dash unit on the right hand side as well. Now, what you've got then is the alarm section. So in here, basically, you can set the maximum and minimum values for each of these alarms. So for the purpose of the video, I've got the air charge temp maximum set at 80. Once the air charge temp actually goes over that value, what you'll find is the alarm will come on. It will show you the value of the alarm, and once it's been displayed once, it will then change the layout to have that item in red. Now, if your layout does not support the item changing to red, for example, on this page, let's go to, sorry, another one here. Let's go on this one, for example. What it will then do is basically, if the air charge temp is not being displayed on the actual layout of the screen, which you can see it's not being displayed there at the moment, then what it will do is it will keep toggling the alarm page. And this is basically set here. So you've got the alarm hold duration. So basically the alarm warning will be present for 3,000 milliseconds. And then the hold off duration is set for 10,000. So what that basically means is the alarm page will be active for say 3 seconds, and then it will not become active again then for 10 seconds until that time has elapsed. Once that time has elapsed, it will then basically bring the alarm page up again on display, and it warns the driver that there is an alarm. You've also got an alarm engine speed threshold here. This one is for the items that are engine dependent. This could be something like engine oil pressure or fuel pressure. For example, you're going to have 0 oil pressure when the engine is not running, so there's no point setting that alarm in doing so. And if you press F1 on this section, it actually illustrates which alarms actually have that feature. You've also got a lean lambda alarm, which is extremely useful. You can set the lean lambda source, whether you want it to be based on manifold pressure or MAF, and then from that you can basically set a desired lambda which you wish to see for that, say, given manifold pressure and RPM. And if the lambda is out of that window, it will basically flash up a big warning on the TinyDash, the same as you can see at the moment on the right hand side, to say lambda is out of range, and warn the driver that there is a lean moment in the engine. You've got the battery voltages and many other alarms here, but the purpose of those is you obviously can set them to each. Now you've also got, and when you do that, you've got an alarm active item as well, which is here, and that actually shows you which alarm is present and being displayed on the dash as well. So you can see here there's none currently, but when that alarm then comes on the actual TinyDash in a moment, you'll see that alarm active change to air temp like so. And that's useful because you can actually send that over CAN bus as well to basically send it to an ECU that will actually put it into a limp mode as well if, for example, a dedicated sensor is wired purely to the TinyDash. Now the alarms are quite powerful, so we've showed that section, and then we're just going to clear the gauges by go GX. We then come to the LCD setup. So you've got basically the LCD brightness. I'm actually first of all going to remove that alarm. It's going to be annoying otherwise. So just unassign that input. So the LCD brightness, you've got day brightness, night brightness, and alarm brightness. Pretty self-explanatory, apart from what basically triggers the night brightness mode. And what you then got is an item on the right-hand side here called headlight. So once the headlight item is on, this actually will change the brightness level to be used from the set the amount here. Now, you've actually got the ability to wire in a headlight switch as an input here, or via a CAN bus. So for the purpose of this, we're just going to wire it in as a input, and then change the input type to here. Well, we're going to leave it actually 0 and 1, program that, and the headlight should then go to on. Now when it does that, as I change the brightness here, you can actually see on the display the brightness level changes to suit. It's not very good with the camera layout here, but it's a useful feature because in some the display is quite bright, and at night time you obviously don't want it glaring and blinding you. Now the alarm brightness is pretty self-explanatory. You can set that to display how bright you want the red. Obviously red stands out quite a lot, so we have that generally at 75, but you can increase that if you want to make it even more prominent. So we talked about we went over the layout, setup, etc. a minute ago, but we're going to just go over the the orientation. So you've got the ability to change the layout. So for example, if you want to rotate it, say you've got this fitted upside down in your car, you can just change that so the landscape then is upside down, as you can see here. And you have the same option for the portrait landscape option, which is used for layout 7, which is just the gear position. Now you've also got the ability to change the text color. So at the moment the text color is yellow for layout 1. You can change that to suit. So let's go back to layout 1 just because it's easier. And then in here we can change the text color to say red if we wanted. You can then change the box color to say gray, and then the background color, if you wanted to, set that to white. So it's quite useful. You can have it set however you want. I mean, that is pretty horrible. I think the black background is quite a nice way, but each to their own. But yes, that is an option. And you can change the alarm color to be the different colors you want as well. You've obviously got the ability to change that for each of the layouts, as you can see here. Now, the one thing that's different with the layout 4, if we just change to layout 4, you've got the line, which is basically showing the value. We've got a fill under line option here, and what that does is basically change that line that you can see on the right hand side to be filled with a solid color underneath. Not everyone needs that, but it's quite useful. I personally prefer the fill under not to be on, but each their own. Then you've got the LCD layout 5. Let's change to that. This is like a boost gauge, for example. Change all the colors and items, etc. You've then got a gauge minimum value and maximum value. That basically changes the kind of breakpoints that go around the circular device. Currently it's set at 0 and 3000. So for this instance, for manifold pressure 1, that's displaying 0 to 3000 millibar. The peak in the top right hand corner will then remember the value that you've got set. So if we just lie to this for the minute and just assign a manifold pressure and remove the high error threshold, and then allow me to change that live. You can see, oh, it's because it's not set as input, so set that low, sorry, to 0. As I change that, it will basically, the peak will actually remember what the peak value was, which is quite useful. But yeah, having the ability to change that min and max value on the gauge is useful as well, that you can set your range that you want to be able to see on the display. Then layout 6, pretty straightforward, that one. It's just basically a gear position, which is always fixed, and then you can just change the 2 items, which are here in the layout set. You can name either the gauge 1 and 2, so either cal position or manifold pressure, and you can change that to say ECT, and then put that on there, so you can see it like that. And then the last layout that you've got is layout 7. Layout 7 is always in portrait. It's just always gear position. All you can do with that is just change the text color and the background color to be able to set it as you wish. So the I/O configuration is the same as our engine ECUs. You've got a car coding option here, which is useful for generic transmit, and then an output testing section here, which allows you to test the outputs. So hopefully this video has been useful in allowing you to get your TinyDash set up. It should be very straightforward for OEM applications or original ECUs that you've got listed in our preset can. But enjoy, and any questions, email support@Syvecs.